This is Elise Gazera and Henry Rydberg, 8th grade science students at Lydian. They are going to present a project today on Brownian motion.
The following is mostly a direct quote from Wikipedia. Brownian motion is named after the botanist Robert Brown, who first described the phenomenon in 1827 while looking through a microscope at pollen of a plant immersed in water. People thought then that the motion was because pollen is alive. In 1905, almost 80 years later, theoretical physicist Albert Einstein published a paper where he modeled the motion of pollen as being moved by individual water molecules, making one of his first major scientific contributions.
This explanation of Brownian motion served as convincing evidence that atoms and molecules exist and was further verified experimentally by Jean Perrin in 1908. Perrin was awarded the Nobel Prize in Physics in 1926. The direction of the force of atomic bombardment is consistently changing, and at different times the particle is hit more on one side than the other, leading to the seemingly random nature of the motion. All the tools for the experiment. You need milk, food coloring to highlight the fat particles, slides, a good microscope, and a hairdryer. You need to understand the functions of the microscope. The light, focus, lenses, etc.
And that is understanding your equipment.
Okay, first I have to put 5 ml in of milk. And then I have to put several drops of food coloring. And then we have to put 30 ml of water.
Okay. It's possible that we might have to add a little more water. The reason we dilute it is because if it gets too dark, it's hard to get the light through the lens.
On the slide. Make sure to use a concave slide. Try to make it just fill the concave dimple on the slide so that when you put the slide cover on the liquid, it doesn't flow out. Flowing can be seen in a microscope and is not Brownian motion. You can tell because the flow means all the fat globules move in the same direction. Brownian motion is all of them moving randomly.
So we did get a little bit of excess there, but that'll settle down after a while. Henry is now placing the slide in place, and he will focus on the lowest level to get it approximately in the right place. We're moving to the higher level magnification. Elise will basically get close so you can make sure that Henry doesn't hit the slide. Let him know if he hits the slide, because we don't want that to happen. This focus is very close to the slide here.
In order to get 1,000 times magnification, we're going to change the eyepiece.
So now we're going to heat up the slide a little bit with a hairdryer. While Elise will observe and see how well the little fat globules are jiggling. When she thinks it's like good enough, we're going to stop the hairdryer because we don't want to overheat.
Is it working?
Yeah, okay, probably stop.
Okay, the last step here is we've got a tripod, and Elise will be recording the motion as we watch it.
Okay, probably stop.
It's looking pretty good.
Pour a drop of the mixture on the slide. Make sure to use a concave slide. Try to make it... Wait, can I start it?
So today we are going to demonstrate Brownian motion with Elise Gazera and Henry Rice. Oh shoot, we are photographing the ground. What's going on here?